Hi everybody, I'm Eli with my partner Tamjid, and today we're going to be doing our engineering ethics analysis of the Chernobyl disaster using our causal loop diagram. And just to be clear, this was not a single mistake, but a system failure.
So before we read this diagram, we have to know that the blue arrow with a plus sign means that the variables are moving in the same direction. So in other words, if one increases, the other also increases. While the red arrow with a minus sign means that they're moving in opposite directions. So if one increases, the other decreases. And some connections here is including delays, meaning that the effect is not happening right away. And this effect is also not visible, which makes it very harder to control. And the dashed oval shows here an internal reaction, specifically that the xenon poisoning which happened inside the core of Chernobyl.
And here at the top of the system, we started with political and scheduled pressure. This pressure increased performance pressure, basically meaning operators were pushed to make ends meet, and they were under really tight restrictions. And that pressure then affected the human behavior, and under stress comes operator complacency, which also increased. Really because people started making shortcuts or risky decisions just to keep up. That complacency led to disabled safety systems, which reduced the reactor's built-in protection. And at the same time, pressure reduced safety protocol compliance, meaning the procedures are a little less strictly followed, and it created really unsafe operating conditions. Now on the physics side, reduced compliance and unstable actions affect reactor power levels, which interact with xenon poisoning, and the xenon started to build up really slow, but it destabilized the reactor, and the operators couldn't see it happening because it was really invisible due to the delay. And from there, the system moved into reactivity and power instability where control starts slipping. Finally, this instability connects to the steam void behavior in the core where more steam formation changes reactivity and pushes the system further out of control. So overall, the system connected the three layers of organizational pressure, human behavior, and the reactor physics, basically.
So now we look at the three reinforcing loop, which is R1, R2, and R3. The R1 means the runaway reaction loop, where the reactivity increases and the steam void increase, and also the positive void compression also increases the reactivity even more. So this is creating a runaway effect. So once the power is just rising, it is just rising without any kind of control. And R2 is complacency cascade. Here the performance pressure increases, where the operator complacency also rises and the safety systems are disabled, which increases the reactor risk and also reinforces a reliance on the shortcuts. So this is actually a human behavior loop where the confidence is being replaced with caution, and this is where things are going in the wrong direction. And R3 is eroding compliance loop, where the political pressure increases and the safety compliance decreases. So the reactor is pushed into an unsafe operation where the xenon instability grows, and which increases the reactivity risk. So this loop weakens the discipline in the system, and all three loops reinforce each other, causing instability.
Now let's put the system on a timeline. First, the political pressure builds as leadership demanded the safety test be completed on schedule. And then next, the operators reduce power incorrectly, and the xenon begins to build up. But this obviously happens invisibly. And because nothing immediately breaks, their confidence increases and their complacency set in. Safety systems are also disabled. Then the hidden delay becomes really important because the xenon poisoning made the reactor unstable, but the operator still couldn't see it. And at that point, the runaway loop triggers, power spikes, steam void increase, and reactivity accelerates really fast. And finally, the system collapsed and led to an explosion and radiation to the public.
So the most important leverage point in the system was the transparency about reactor behavior, especially the positive void coefficient, which the operators had no idea about. So if the operators knew about this R1, R2, R3, all these three reinforced loops would have never been occurred. And this was mainly an ethical failure in communication from the higher up, and so leading to all three feedback loops to escalate unchecked.
Overall, Chernobyl was not just the result of one mistake, but it was a systems failure driven by all three of our loops, and also a critical delay and the missing transparency in the system. The key lesson from this is simple though. Systems fail when pressure, design flaws, and human decisions align without proper safeguards or honest communication. Preventing disasters like this is not just about better engineering, it's about accountability, transparency, and ethical responsibility at every level of the system. Thank you guys.
Thank you.